Okay, hello. What I'm going to do, we are going to continue. I'll talk about the polar form or polar coordinate the other night. We introduce a function and equation in polar form, and we give it a graph of those equations. So what I'm going to do, we're going to bring the concept of calculus to see, for example, the problem of a tangent line. We're going to find the slope of a tangent line when your equation is in polar form, and how we're going to find the arc length of the graph, or eventually how we're going to find the area under the curve. All of them can be done by integral of the function in a rectangular coordinate system. Now we're going to do it for the polar one. Okay, so quite interesting, and that give you the idea of how we're going to use this type of format for the application in future. Okay, so let's see how far we can go. So I go to my notebook. We try to finish these ideas so we can give you your last quiz, and then we prepare for the final. Okay, so we just continue with that 10.3 that I talked about the other night. It's very dense section, and I just keep going and give you all this format that we're going to have. Okay. So what we would like to know, what's going to be the situation of the tangent line. Okay. So what is going to be our situation with the tangent line? The main problem of the calculus. Okay. What is tangent lines? What is tangent line to polar curve? Polar curves. You know that in the case of the usual tangent line problem, the idea is to find the slope. So we can find the slope of a tangent line if the function is given to you in terms of y equal to the f of x. Then you know that f prime is going to be the slope of the slope of a tangent line. So how we're going to do it if your equation would be given to you in polar form? The equation in polar form is going to be in the term of, let me just remind you. Okay, so we suppose r equal to the f of theta, and instead of x, y equal to the f of x is the differentiable function. Okay, it's going to be a differentiable function. So we can differentiate the r respect to the data. Now, in order to find the slope of a tangent line, to find the slope of the tangent line of the tangent of a tangent line to the graph of this function, okay, to polar curve. Polar curve. So it's going to be polar curve of the or curves of this equation are equal to the f of theta. So you know that the slope of a tangent line basically is going to be d by dx. When when the function y is going to be a function of x. So this function would have a representative in xy coordinate, and now we are going to getting back to that one. So what is going to be a relationship between x and the y and r and the data? So we have, you see, you know that x is r cosine of the data in the polar form, which is going to be equal to, you substitute for r, that give a f of theta, whatever it is, times cosine of the data. And what is going to be y? And the y is r sine of the data. You know that y is going to be on the y coordinate, or the vertical one, which is the sine. The other one is horizontal, which is the cosine. and you substitute for r, so that give f of data times the sine of the data. Okay, so this is a situation I'm going to have for the x and the y. So if this is going to be x and the y, then you know what's going to be the slope. Then the slope of the tangent line is like a ordinary one is defined by, okay, it's defined by, that's it. This is the slope. M, the slope, is equal to y is equal to the derivative, which is a dy dx. But the x and the y are going to be a function of r and theta. So in order to get to that one, we think about it as, okay, dy would be dy d data, differentiate with respect to the data, and this is going to be dx d data. Okay, because the y and x are a function of data. So what we're going to do, you have to find the dy d data and dx d data from these equations and come back, and that gives us the formula. Okay, I'm going to find the formula, then you can memorize it and use it anytime you like. Okay, so let's see. I'm going to differentiate the y here, differentiate the y respect to the data. So I'm going to have what is going to be the dy d data is a product of two functions. Function of the data, derivative of the first times second, second first. So derivative of the first one would be f prime of the data times the sine of the data, plus derivative of the second times the first. Of the sine is cosine, so it's going to be f of data times cosine of data. Okay, so that is going to be dy d data. The same thing for the dx dt. Dx d data is equal to, again, this is your x. Now differentiate it. Derivative of the first times second, second first. So it's going to be f prime of data in terms of the x times cosine of the data. Plus derivative of the second times first. Derivative of a cosine is a negative sign. So we get the negative f prime of data times, times sine of the data. So, you know, it's easy to memorize because the f prime and the f data, both of them are the same. So we get a sine, cosine, cosine, sine. So if you go back and you can keep the f prime, which is fine, or otherwise you can, you know, that this r is f of r, if f of theta is the same as differentiated respect to the r. Okay, it doesn't matter to get this one. So if you go back and put it here, then you are going to have a formula for this slope. So what's going to be the slope? The slope is going to be dy dx. So the top is going to be f prime of theta times the sine of theta plus f of theta times cosine of the theta. Okay, so this is going to be the case. Just turn this one on. Okay, so this is going to be the case. Now down the bottom is going to be the same thing. It's going to be f prime of theta times the cosine of the theta minus f of theta times the sine of the theta. Okay, so this is going to be the formula for the slope. Anytime you want to find the slope of the tangent line into the polar form, this is going to be a situation you can do. Okay. This can be also written down in terms of the r. You don't have to add. This is another option. I don't like the f prime, so this is going to be like, remember this is drd data, drd data, and that's the sine of the data, and f of data is just r. So it's going to be plus r cosine of data. And the bottom one is going to be drd data, cosine of the data minus r sine of the data. It doesn't matter. You can, can substitute anytime you like. Okay, so this is going to be the slope or these numbers. You can bring all these formulas, of course, to your test, and you can use it. You don't have to, but it's not bad if you can memorize it. Okay, so the examples are going to be just easy function would be given, and you've been asked to find the slope for us. Give one of them. Okay, so the example is going to be a function would be given, and they ask you for, so would like to find the slope, find the slope, find the slope of the tangent line, to the curve, to the graph r equal to the cosine of theta. We talked about the other night. This is going to be a circle. Okay, at the point where this is the way how you are going to give it a question. Theta is equal to the pi 4. Okay, that's it. So this is r, which is the same as f of theta. Whichever formula you want to use. So this is it. Solution. So you can write the formula right away, or you can find the f prime of theta, then go for it. It's up to you. Okay. So I prefer to find the f prime, then I substitute. So that's it. This is f of theta is 4 cosine of the theta. So f prime of theta, I differentiate derivative of 4 is 4, derivative of cosine negative sine. So negative 4 sine of the theta. So I'm going to put these two here. Okay, f prime, f of theta, and then we continue. So this is it. Go to the next page to continue. Okay, so I'm going to use this formula. This is the formula that we have, and this is f of theta and f prime of theta. I substitute, and then I evaluate that theta equal to the pi 4, and then we're done. Okay, so this is going to be the slope when you substitute those formula. So the m is equal to, where we have the f prime of theta, so the f prime was okay, so that's on the top, f prime of theta times sine, the f prime is negative 4. Okay, so that's it. It's a negative 4 sine of the theta. Okay, it's multiplied by sine of the theta. Okay, and it was plus f of theta. F of theta is just 4 cosine of the theta. Okay, times it by, okay, so times by cosine of the theta. The bottom one, negative 4, f prime is going to be the same. It's we just switch the cosine and the sine. So it's going to be negative 4 sine of the theta. So now you're going to have a cosine. Okay, you have a cosine of the theta, but it's going to be minus. Again, this f of theta would be the same. You get 4 cosine of the theta, and you times it by sine of the theta. Sine of theta, that's it. Okay, you can simplify it if you like, and then go and substitute, or just substitute right away. I just show you if you want to simplify it. This is going to be negative 4 sine square of the data, and it's going to be plus 4 cosine square of the data. And the bottom one would be negative 4 sine of theta cosine of theta. Okay, and this is going to be again negative 4 cosine of the theta sine of the theta. Okay, you can use some trigonometric identities if you like, or just write it down as is. So this is going to be the case, and the bottom one would be negative 8 sine of the theta cosine of the theta. Okay, and the number is pi 4. Okay, it's going to be n, but you want it at pi 4. Now you substitute. You substitute the pi 4. So this is it for this specific number. So m is going to be equal to negative 4 sine square of the pi 4. Okay, plus 4 cosine square of the pi 4. And divide by negative 8 sine of the pi 4 cosine of the pi 4. Sine is pi 4 and cosine of the pi 4 is radical 2 over 2. So m is equal to, this is going to be negative 4 radical 2 over 2 all squared. And that's going to be a positive 4 radical 2 over 2 all squared. And the bottom one is going to be negative 8 radical 2 over 2 times a radical 2 over 2. At the top, you see these two are the same. Negative 4 radical 2, so these two would cancel out. The top would be 0. When the top is 0, you know that. And the fraction would be 0. Because the top you get 0. And down the bottom, radical 2 times radical 2 over 2. You don't need to find it really. That give you 2, 4. Okay. So it's going to be 8 times 2 quarter. Okay, which is going to be 0 over 2 times 8, 16, negative 4. But the result is 0. So the slope of a tangent line is going to be equal to 0. You know that when it's a 0, it's going to be, the tangent line is going to be horizontal. Okay, so this is how you're going to find it to get these numbers done. So this is going to be one problem of the tangent line. But as we did it with the problem of a tangent line for the function of one variable, okay. As we did it for the function of one variable, sometimes we'll be interested in the horizontal tangent line or the vertical tangent line. In the case of the function of one variable, if the slope is 0, so the tangent line will be horizontal. Okay, and when the slope is infinity, that would be a vertical one. But for this case, this is what we are going to have. Okay, so how we're going to finally give you a remark. You are interested in the horizontal tangent line or the vertical tangent line. Okay, so the first part is going to be horizontal one. You want the y to be equal to the something. So you don't need the x. So this is the situation we're going to have. So a horizontal, okay, a horizontal tangent line will occur, okay, where dy, the theta is going to be equal to 0, because in that case y will be a constant, which is going to be horizontal, but you must make sure that the denominator of that formula dx d data is not equal to 0. Okay, because the top of the fraction would be 0, so the slope would be 0. When the slope is 0, so the tangent line is going to be okay, horizontal. If this is going to be 0 at the same time, you get 0, 0. Okay, it's going to be indeterminate form. So that's the case 1 for the horizontal tangent line. For the vertical one, the equation of the vertical line is x equal to. So in that case, dx d data must be 0. So that gives you x constant. But the d by d, the other one is going to be a non-zero number. Okay, so a vertical tangent line will occur where, in this case, dx dt must be 0. But make sure that the other one is not 0. D by d data is not equal to 0. So you have to solve these equations and then get the common solution to get these numbers. So this is the case, and there is a case that if both of them are 0 at the same time, the result is called a singular point. Okay, so a singular. You have it in your assignment, so we want to make sure you know it. A singular point, again, will occur where these two would be 0. So dy d data is equal to the 0, and dx d data would be 0. Okay, so one problem would be given to you, and we are going to ask for those points. You need a little bit of trigonometric functions, okay, the idea to be able to solve the resulted equation, but otherwise it's going to be very, very nice one. Okay, so I'm going to give you one, and we give you one of them in your next test. Okay, and you have a couple of them in your book for your assignment. So let me explain it. This is the type of example that we are going to have. Okay, we are going to consider a card here. Remember the heart shape. So this problem is usually, the problem would be in two parts. Okay, part one. Part one, we want to find the slope. Find the slope of the tangent line. The slope of the tangent line. Slope of a tangent line of the cardioid. The best example is going to be the cardioid. Okay, this is it. And that's a cardioid. R equal to 1 plus sine of theta. When we want it, when theta is equal to the pi third. So that's the first part of the problem, and the second part, they ask for the points. So I would like you to find the points. Okay, find the points on the graph, on the cardioid. Okay, where the tangent line, where the tangent lines, okay, are going to be, tangent lines are horizontal or vertical. That's the most general problem for the tangent line problem in the polar form. Okay, that's it. Solution, you don't need to graph it, but I just want to remind you when the graph is not bad, quickly you can graph it. is the coordinate with a sign, so it's going to be either up or it's down. If it's going to be cosine, it's going to be to the right or to the left. A couple of numbers will tell you, okay, this is going to be r equal to the 1 plus sine of theta. If you want to graph it, again, you don't have to, but I just want to remind you how we're going to graph this coordinate. Okay, just a couple of points. You see, this is going to be the theta, and this is going to be r. So we start with a 0. Sine of the 0 is 0, so that equals 1. Then you can go to the pi half. Pi half is 1 plus sine of the pi half. Sine of the pi is 1, so that gives you 2. Okay, then you go back to the pi. Sine of the pi is 0, that gives you 1 again. Okay, that's going to be half of the coordinate. Then you can continue. If you go with the 3 pi half, the sine of the 3 pi half is a negative 1. So 1 minus 1 would be 0. Okay, it would be 0. And if you go with the 2 pi, the sine of the 2 pi is 0, that gives you 1. You can get something in between, but just give you the idea of what's going to be the shape of the graph. Okay, so when data is 0, r is equal to 1. So this is going to be 1. Okay, that's going to be the first point. Okay, and then when we get to the pi half is 2. So that's going to be 1, 2. Okay, so this is how you go from here. Okay, this is how you go from here. So when we get to the pi, is going to be 1 again, so it's symmetric. So that take you down here. Okay, and when we go to the 3 pi half, is going to be 0. So it's go to this side, and the 2 pi we get 1. So this is going to be the coordinate. Okay, just give you an idea of what's going on. So as you can see, if you want to consider the horizontal tangent line, you say look at this one, you have 1, 2, 3. And if you want to get the vertical one, you get 1 here. Okay, the vertical one is going to be 1, 2. So that gives you an idea of what's going to be happening. Let's just give you, an idea how to graph it quickly. So let's take the first part. The first part, you want to find the tangent line. You know what to do. You know the formula. So the slope formula, the slope, which is dy dx. Okay, so the formula was this is it, f prime of theta sine cosine, the sine of the theta, plus f of theta cosine of the theta. The bottom one is the same here, but you change the sine into the cosine, and it's going to be negative f of theta times the sine of the theta. It's very easy to remember this formula. Okay, so your function is 1 plus sine of the theta. So you differentiate it, f prime. So f prime would be the derivative of 1 is 0, so that you will cosine of the theta. So go back and substitute over there. So this slope is going to be equal to f prime over theta is cosine, so that gives you cosine of theta, sine of theta, plus f of theta. It's a 1 plus sine of the theta. Okay, times cosine of the theta. Okay, cosine of the theta, and the bottom one is okay, so the bottom one is going to be f prime of theta, which is cosine of the theta. Okay, times cosine of the theta. So this is going to be minus f of theta is 1 plus sine theta times sine of the theta. Okay, So we can simplify it on the top. You have to distribute it to simplify. So this is it. So that's the cosine of the data, sine of the data. You multiply. So that gives you cosine of the data plus sine of the data, cosine of the data. And the bottom one is cosine squared. And if you multiply, that gives you minus sine of the data and minus sine squared. Sine square of the data. Okay, on the top, this would be 2. So it's equal to, okay, cosine of the data plus 2 sine of the data, cosine of the data. And over here, it's going to be unchanged. Okay, so we have cosine square of the data minus sine of the data minus sine square of the data. So this would be m. Okay, this would be m. And now you want to add pi third. So you let the data equal to the pi third, substitute to get the slope. So the slope is going to be, so that gives you cosine of the pi third plus 2 sine of the pi third, cosine of the pi third. The bottom one would be cosine of the pi third squared. Okay, minus the sine of the pi third minus the sine of the pi third all squared. You have to be patiently evaluate this. Okay, pi third is 60 degrees. So and the cosine is going to be 1/2. So we continue. We substitute. Okay, that gives you half. This is it, that gives you 1/2. 1/2 plus 2 sine of the pi third is radical 3/2. The cosine is 1/2. And over here, the cosine is 1/2, so that makes it to the 1/2 squared. Okay, minus the sine is radical 3/2. And again, we get a minus radical 3/2 all squared. So simplify, go forward. Okay, so what's going to be on the top? And this is going to be 1/2. Now, one of the two is cancelled out, so that gives a radical 3/2. That's radical 3/2. Okay, and the bottom one, it's going to be 1/2, it's going to be 1/4. This is minus radical 3/2. And that would be minus radical 3 squared would be 3/3. Okay, now 1/4 and minus 3/4 would be negative 2/4, which is a negative 1/2. So the top would be 1/2 plus radical 3/2. The bottom one would be negative 1/2 minus radical 3/2. You see, as you can see, they are opposite of each other. So it's so the top one and the bottom one, you see, if you factor out the -1, they are exactly the same. So we can simplify it. These two would cancel out, and the result would be -1. So the slope of a tangent line as pi third would be -1 to get these numbers. Okay, so this is going to be the first part, getting the slope. Okay, now then they ask for the horizontal and the vertical one. So what you have to do is you have to solve, let me talk about it. You have to let the top to be equal to the 0. This is dy d data, and you let the bottom to be 0, and then get the points where one of these dy or dx is 0 and the other one is a non-zero number. So I'm going to go to the second part. It takes times, okay, for the other two, but it's not bad. And you can do it. So that was the first part. Doing the second part, So remind yourself that the dyd data is the one that we got on the top here. Okay, on the top of this fraction, when you write on the tables of the cosine, see that is the dy, and this is the dx. So I'm going to bring them here. So dyd data is going to be equal to, okay, so that's the cosine of data plus 2 sine of the data, cosine of the data, and the dx dt, d data is going to be the denominator, and the denominator is cosine squared, okay, cosine squared of the data minus sine squared. Okay, remember to have the horizontal, you have the dy equal to the 0, but this is not going to be 0. So you better let both of them to be equal to the 0, find the solutions, and then come back and decide which one is going to be which, if you like. Okay, so we did the dy d data to be equal to the 0. You have to solve a couple of equations for us. Okay, that would be cosine of the data plus 2 sine of the data, cosine of the data equal to the 0. You have to solve this equation. You can factor out the cosine of the data. So cosine of the data, that gives 1 plus 2 sine. Okay, let this factor to equal to 0. Cosine of the data equal to the 0. You know that. So what we're going to get is going to be cosine of the pi half. Okay, so the cosine of the pi half is equal to the 0. The cosine of the 3 pi half is also equal to the 0. So we get these two solutions. Okay, from the first part. Then you let y plus 1 plus 2 sine of the data to be equal to the 0. So that gives the fact that the sine of the data is going to be negative half. Okay, it's going to be negative half. So it's a negative, so it's going to be on the third and the fourth. You can check with the unit circle. So the positive one is going to be 30 degrees. So we go to the third. It's at 210 and 330. So the data is going to be 210, which is 7 pi, okay, 7 by 6, and 330 degrees, which is 11 by 6. And you can get this from the unit circle. So basically, dy d data equal to the 0 would imply that data is equal to the pi half. Okay, 7 pi half, 7 by 6, 210, then 3 by 2, 270, and 11 by 6. So these are the possibilities for getting a horizontal tangent line, but you have to exclude the zeros of the denominator. So you have to continue and taking, so that was when the yd data is 0. So we have to repeat it for dx d data. This is a dx d data. Try to solve this equation. Okay, so the dx d data equal to the 0. So that gives you cosine square of the data minus sine square of the data minus sine square of the data equal to the 0. We have to solve this equation. It's a kind of quadratic one. We have to change it to this, anything into the sine. So we replace cosine square by 1 minus sine square of the data. And that's 1 minus sine and negative sine square of the data. You combine these two together, that gives negative 2 sine square of the data minus sine of the data plus 1 equal to, okay, equal to the 0 to get this equation that we have. Okay, So that is going to be the case. You can solve this equation using quadratic formula. You can multiply by negative sign to make it easier to factor. I say that's going to be the one. You can use quadratic formula or just factor it. Okay, if you factor it, that give you sine of the theta plus 1 times 2 sine of the theta, okay, minus 1. Or you can use quadratic formula. So you have the sine of the theta plus 1 equal to the 0. So that gives you sine of the theta equal to the negative 1. Okay, and you know that in this case we have only one solution, and that is going to be theta would be 3 by half. Okay, so you can use the table 3 by half, unit circle chart if you like. And if 2 sine of the theta minus 1 is equal to the 0, so that gives you the fact that the sine of the theta is 1/2. So the solution are going to be, it's 30 degrees and 150 degrees. So it's going to be by 6, okay? By 6 and the 5 by 6. So there you are. So dx d theta would be 0. And okay, if this is going to be the case, then your data is going to be, you have 3 solutions here, is a pi 6, okay, 5 by 6, and 3 by half. That's it. So let's see what you want to do. Okay, for horizontal line, for horizontal tangent line, you see horizontal tangent line, horizontal tangent line. Remember the condition is that the d by dt, d data b0, but dx dd not 0. So you cannot have a, you know, a common solution. So look at these numbers that we have. Okay, so I just put them together so that we can see it. You see dy, so dy d theta equal to the 0. That gives you the fact that the theta is equal to the pi half. Okay, pi half, 7 by 6, 3 pi half, and 11 by 6. If dx d theta is equal to the 0, so your theta is pi 6, 5 by 6, and 3 by half. So in this case, you have to see, you can accept any point of the first part. It is not going to be here. Okay, so you have the theta equal to the, you see the pi half is not here, so we get the pi half. Okay, that's it, we get the pi half. 7 by 6 is not here, so we can have the 7 by 6. 7 by 2 is here, so you cannot pick this one. And you can pick the 11 by 6. So this is where we get the, okay, we get the horizontal tangent line. This is the horizontal tangent line. Now the vertical tangent line is the other way around. Okay, so this is horizontal tangent line. The vertical tangent line, dx can be equal to the 0, but not the y. So you get a theta equal to the pi 6 makes this one 0 is not here, so pi 6 is good. 5 by 6 is not here, 5 by 6. 3 pi half is here, so we cannot pick this one. So this means you are going to have 2 vertical tangent line and 1, 2, 3 horizontal one. And that's exactly how we see it here. Let's look at this one. You have 2, you see 1, 2. 1, 2 vertical okay, vertical tangent line, and you have three horizontal ones. You see 1, 2, 3. That's it. So you see two vertical 8x6 and the 5x6, and you get 1, 2, 3 horizontal one. Okay, they cannot. If you, both of them at the same time is going to be 0, you're not going to pick that point. So for horizontal one, I focus on this one, divide the data to be 0. So I check these points. If they are here, I drop it. The other way around, you have to check a dx dt. You have to have a dx dt to be 0, but not the other one. So that gives you the equation of the tangent line. Okay, it's very nice and not difficult. Just make sure you understand it and make sure which formula are going to use. You see, that's it. The proper formula. So that would take care of okay, that would take care of our first problem in polar form, the problem of the tangent line. Let's get also arc length, so we can do 2 tonight, and then we leave the area for another session, and we finish it. Okay, now the other very famous problem and interesting one is going to be problem of the arc length. Arc length in polar form, very popular, many applications. If you're heading for something measures in, okay, the measures in physics, you got to be careful, or anything in engineering. You have to go through this type of measurements, because there's going to be a special integral in calculus 3 that depends on the arc length. Okay, so there you are. So arc length in polar form. Arc length. Okay, in polar curve. Polar curves or of the polar curves. That's it. Again, we are going to set up the formula for you, and then you memorize the formula and substitute the result. This is straightforward. So what's going to be the question again? We have a function, say this type of equation. Suppose R is equal to the f of theta. Okay, and this is going to be a function. Okay, is given. It's given. So in order to find a gain, I'm going to prove it for you. In order to find the arc length formula, the arc length formula in polar form. Again, you see we have the same thing that we did for the tangent line. Okay, you already got it, just repeat it. Remember, x is equal to the r cosine of the theta. So you substitute for r, so that you f of theta cosine of the theta, and the y is going to be r sine of the theta, which is going to be f of theta sine of the theta. Okay, so we already got these formulas. Okay, we find the derivative. You see the dx d theta. Remember, use the product rule, or we can do it again. Use the derivative of the first times second, second first. So f prime of the theta times cosine of the theta, and the second first would be f of theta sine of the theta. Okay, and we differentiate the y. This is the one that we did. Derivative of the first times second, again, that give you, we change the sign. F prime of the theta, cosine of the theta. I'm sorry, f prime of the theta, derivative of the first times second, sine of the theta. And plus derivative of the second first would be, okay, the derivative of the second is cosine. So that give you f of theta cosine, as we did it before. Okay. Now to get the arc length formula, we need to find the length of these. Okay, it's like a kind of particular identity. Dx d data squared plus dy d data squared. Okay, so this is going to be the case, in a bit of algebra to simplify it. So it's going to be f prime of the data, cosine of the data, minus f of data, sine of data all squared. The first one, and you're squaring the second one. F prime of the data, sine of the data, plus f of data, cosine of the data all squared. Okay, if you square it and factor out, you get lots of sine squared plus cosine squared. Everything would be simplified. So the result is going to be, you see, this is going to be a square, cosine square. This is going to be a square, sine square. You factor it out, sine square plus cosine square would be 1. So this is going to be f prime of theta all squared plus, then the same thing for the f of theta. F of theta all squared. See, that's going to be the 1. But remember, this is r squared, and this is the derivative of the r, or just f, it doesn't matter. You can work with this one or just make it easier, okay, for yourself. I just remind you that bet, you see that r is f of theta, and dr d theta, or r prime, is f prime of theta. So substitute here. So that's it, dx d theta all squared plus dy d theta all squared would be what? Would be dr d theta squared, derivative of the function, plus the square of a function, r squared. So the arc length, L for arc length, is going to be integral from a to b. Okay, we take the square root of this, square root of r squared plus dr d theta all squared, then you differentiate, integrate it. So that gives you arc length formula. Arc length formula. Okay, so this is going to be the function. The function is here. You can call it f of theta. If you like, some people like this format. If you like it, you can use it. You see, this is f of theta all squared. And this is what? This is f prime of the theta all squared. Just use, whichever you feel more comfortable for the arc length formula. Okay, you square the function and you have to differentiate it and square the derivative of the function, or just use r squared plus dr over d theta. Okay, so this is going to be the arc length formula in polar form. Okay, so give one example. Again, the best example is going to be a cardioid. So it's going to be example. We want to find. Okay, we'd like to find. We want to find what? Find the length of the arc. Find the length of the cardioid. Okay, cardioid. That's it, with the equation of r equal to 1 plus cosine of the theta. That's it. So to give you an idea, again, you can graph it. Again, those points would be helpful. So that's going to be the theta and the r. You see, replace the theta by 0. Cosine of 0 is 1, so that gives you 2. Okay, so if you replace it by pi half, cosine of the pi half is 0, so that gives you 1. If you replace it by pi, cosine of the pi is -1, so that gives you 0. And if you replace it by 3 pi half, cosine of the 3 pi half is 0, so that gives you 1. Okay, and if you go with the 2 pi, cosine of the 2 pi is going to be 1, and 1 would be 2. That gives you an idea of what shape of graph, what type of graph are we going to have. You see, it's like coordinate of the cosine is going to be directed to the right or to the left. For the sine is directed up or down. So, you know, if just get there a couple of numbers here, 0, 2, so that's going to be 2. Okay, and pi half 1, so at pi half we get to the 1 here. Okay, and at pi you come back to the 0. So that gives you 0 here. So this means it's going to be the shape of the graph. Okay, and it's symmetric. You can get the bottom one right away. At 3 pi half, that gives you 1. Okay, so this is going to be the 1, and at 2 pi, you come back to the 2. See? Nicely, you can find it. So it's going to be directed to the right or to the left in this case. So the arc length means going around. Okay, going around and find it. You can do it between 0 and 2 pi, or you can find one portion to the top and you multiply by 2. Okay, so you have 2 choices. So the data is going to be between 0 and 2 pi. Okay, 0 and 2 pi to get it. Okay, so let's see what's going to be the shape of the integral that you are going to find for us. So the formula is going to be the arc length is going to be 0 to 2 pi. Okay, 0 to 2 pi. And the formula is r squared plus dr data all squared. So you have to differentiate the coordinate. Okay, so the r is 1 plus cosine of the data. So the dr dt, or just f prime, is going to be derivative of 1 is 0, derivative of a cosine negative sine. So go back. We simplify this one as much as we can, then we go back. Okay, so r squared, and that's a dr d data all squared. So r is 1 plus cosine of the data all squared, and this is going to be the derivative plus negative sine of the data all squared. So they square this one. So that gives a square of the first, twice of the first times second, 2 cosine of the data plus cosine squared. And this is going to be plus sine squared. And you know that sine squared plus cosine squared is 1. So that would be 1. So that gives us a 1 plus 2 cosine of the data plus 1. So it's going to be 2 plus 2 cosine of the data. Okay, so this is going to be the case. So we'll go back, it's going to be inside this radical, of course. So, you know, it's going to be a little bit technical, but it can be done. So it's going to be 0 to 2 pi. And you have the inside. Now we get the 2 plus 2 cosine of the data, d data. But you have to use the fact that, you see, you can factor out the 2 here. So it's going to be 0 to 2 pi. You factor out the 2 and you put it out, so that you have radical 2 and radical 1 plus cosine of the data. Okay, d data. So you can use the half angle formula for this one. Okay, the half angle formula is the cosine square of the data, or data half, is going to be equal to the 1 plus cosine of the data, and which is going to be divided by 2. Okay, so, or 1 plus cosine would be 2 times. So it's going to be 0 to 2 pi. This is already a radical 2. And now this is going to be 2 cosine square of the data half. Okay, this part when you get to the Cartesian is important, and it's going to happen for all of them. So again, this would be 0 to 2 pi. Okay, that give a radical 2, the radical 2. And the cosine is going to be the absolute value of the cosine of theta half, but it's a positive. So that gives just cosine of the theta half, d theta. Radical 2 times radical 2 would be 2. So this is going to be simply 2 integral from 0 to 2 pi. Okay, cosine of the theta half. And you integrate it. Its integral of the cosine would be sine of the theta half, but you have to divide it by 1/2. 1/2 used to reciprocal. Okay, 2 times 2 would be 4. So that gives you 4 sine of the theta half. To be evaluated from, okay. So in this case, we are going to evaluate it. Yes, evaluate from 0 to 2 pi. Okay, then if you go for it 0 to 2 pi, that gives you 0. So you have to divide it in 2 parts. You see, look at this one. You see the top and the bottom are opposite of each other. So if you add them together, we get 0. Because this must be a positive number and this must be a negative number. So what you can do is you can simplify this one before going to the integrations. Okay, this is 0 to 2 pi. So you can find the 0 to pi and then come back and just do it. Otherwise, this would be 0. And then you got to be careful not to take this one. Okay, so I explain it. You see, this is the situation that you have a 2 times 0 to 2 pi. This is where we got it. And that was the cosine of the theta half, d theta. So you can find 0 to 2 pi only. So it's going to be 2. Then you multiply by 2. 2 times 0 to 2 pi. Cosine of the theta half, d theta. Okay, we find the portion to the top. You see, 0 to 2 pi, 0 to pi, and then you multiply by 2. Then you are not going to have that difficulty that I talk about it. So this is going to be equal to the, okay, so now it's going to be equal to the forward, the same thing that we did. Okay, so the integral would be sine of the theta half and divided by the half, but to be evaluated from 0 to pi. So you switch this one, that give you 8 sine of the theta half from 0 to pi. If you substitute 8 times the sine of, if we put the theta equal to the pi, that give you pi half minus the sine of the 0. The sine of 0 is 0, the sine of the pi half is 1. So that give you 8. And it's very famous identity that the arc length of a cardioid is equal to the 8. Okay, so you got to be careful when you're operating this one. You see the top and the bottom are mirror image of each other, but one of them is above, the other one is below. If you don't break it, you get 0 automatically. Okay, so that's why I changed it. Get these numbers. Okay, so this is a very popular case. The arc, you have to know it, but you can have any other function to get the arc length. I do the circle. The arc length is the same as the circumference of the circle, but we just want to use this idea that we talk about it. Okay, look at this one. And you want to find the arc length. And the arc length of the polar curve. So I give a couple of them. See, the first one is this one, R equal to the 3 sign of the data. It's a circle. Okay, it's going to be a circle with the radius of 3/2. Okay, I bet we wanted to find it between 0 and pi third. Okay, that's one. So you write your formula and find it. So the solution is going to be, this is going to be the solution, the arc length is going to be 0 to pi third. Okay, the square root of r squared plus dr d theta all squared at the d theta. So we are going to find it. Okay, that's easy to differentiate. So your r is 3 sine of the theta. So you differentiate with respect to the theta. Derivative of the 3 is 3, derivative of a sine, cosine. Okay, so from this one, simplified first, r squared plus dr d theta all squared. R squared means 3 sine of the theta all squared plus 3 cosine of the theta all squared. You see this one. So that gives you 9 sine squared. And that gives you 9 cosine squared. We know that if you factor out the 9, so that gives you sine squared plus cosine squared, which is 1. So this would be 9. See, so and the radical, you are going to get you get the 9, so put it and go and substitute over there. So it's going to be 0 to pi third, the square root of 9. Because this is it, r squared plus dr d theta is equal to the 9. D theta, so simply it's going to be 3. So integral of the 3 would be 3 theta to be evaluated from 0 to pi third. So it's going to be 3 times pi third plus 0, which is pi. So the arc length of this, this circle, if you like, is going to be equal to the pi. Okay, so you can have various form of the function. Okay, so be ready for it. So I give you one exponential one, which is very popular again. So that's a circle caveat. And we are going to have a couple of more when we give you the practice quiz. Okay, so just make sure you use the proper formula. Otherwise, it's not going to be a big deal. Okay, let me see. Oh, I give you this one. This is better than the exponential one. Yes, just to get to know that you can have various format. You see, so that was number 1. So get this one, number 2. So they give a graph of equation of this r equal to the data squared. Data is going to be between 0 and 2 pi. This is your equation. You want to find the arc length. Okay. What's going to be the solution? Again, the formula is arc length from 0 to 2 pi. The square root of r squared plus dr d theta all squared and the d theta. So that's r. Differentiated. Dr d theta is simply going to be 2 theta. Because just r is theta squared. So from this one, what is r squared plus dr d theta all squared? Okay, so it's going to be theta squared plus the 2 theta squared. So that give you data to the fourth, and then give you 4 data squared. Remember, you want to take the square root here. So you better take the square root. The square root of the data 4 plus 4 data squared. We can factor out the data squared. So that your data squared plus 4. Now we can take this one out. Data times data squared plus 4. So that would be easier now to integrate. So go back. L would be 0 to 2 pi. That's it, data. You change it because you want to integrate it. That's it. Substitution, you see the derivative would be 2. You need a 2 here. So I do the shortcut. So that's going to be 2 data. And that's a data squared plus 4 to the half d data. So that's it. This is the u, and the rest of the u from 0 to 2 pi. So it's going to be 1/2 data squared plus 4 to the 3/2 over the 3/2 to be evaluated from 0 to 2 pi. See, that's it. It's going to be, you flip the 3/2 is a 1/2 2/3 data squared plus 4 to the 3/2. So these two will cancel out, you get the 1/3. I'm sorry, that's yes, that's correct. It's a 1/2 and get the 2/3. That these two would cancel out. Okay, so I'm going to get the 1/3. So the 1/3 data squared plus 4 to the 3/2 to be evaluated from 0 to pi. You can use your calculator to find these numbers. Okay, I don't have. So it's a 1/3 pi squared plus 4 to the 3/2 minus 1/3 data equal to the 0, that give you 4 3/2. So we can use the calculator to find these two numbers. That's it. That would be enough. So study this one carefully. Okay, it's going to be used quite a lot. It's different from what you used to apply, but it's not bad. It would be very useful. Okay, so that's the problem of the arcnet. What we are going to have is going to be a problem of the area between two curves and just area under the curve. I'll talk about that one next time and give you some examples. Otherwise, we are done. We're not going to do anything else. And that would prepare you for Calculus 3 in case you want to take that course. Okay, so I will check. I'll check for the final review and the practice quiz. I post the practice quiz for you. We go over it, and I also post the final review. Let me know if you have any question. Okay, have a good one. Take care. Bye.